Hello everyone. In this video, I'll discuss the issues that arise when we try to transfer a pulse across clock domains, whether from a high frequency clock domain to a low frequency clock domain or the other way around, using only a basic 2-flop synchronizer. Let's begin with the high to low frequency clock domain transfer. Consider the waveform diagram. In the source clock domain, we have a pulse signal called pulse underscore sig. A pulse over here means that a signal which goes high for exactly one clock cycle in CLK1 and then returns to low. During the transfer, when the 2-flop synchronizer in clock domain CLK2 samples this pulse signal, it only captures its value at the rising edges of CLK2. Because CLK2 has a lower frequency, the entire duration of the pulse may occur between two rising edges. And if that happens, the pulse will never be observed in CLK2, meaning it can be entirely missed during the transfer. Any logic or functionality in the destination clock domain that depends on detecting this pulse will either miss the entire event or behave incorrectly. Now let's look at the opposite situation, transferring a pulse from low frequency domain to a high frequency domain. Here CLK1 is slower and CLK2 is faster. A pulse, denoted here by pulse underscore sig, is generated in clock domain CLK1 and it is 1 clock cycle wide. When this signal is transferred to a much faster CLK2 clock domain, it is sampled at several rising edges of CLK2 and the pulse will last for several clock cycles of CLK2. As a result, the destination clock domain sees the pulse as a stretched signal, not a single cycle event. This creates a problem. Any logic in CLK2 clock domain that expects a clean single cycle event may instead react multiple times. In this transfer, the pulse isn't missed, but it is not a clean 1 clock cycle pulse. This makes the downstream behavior unpredictable. So we can see that in both the directions from high to low or low to high, simply using a 2-flop synchronizer is not enough to safely transfer a pulse. To reliably transfer a pulse, we use toggle-based synchronizer, which is an enhanced design with a 2-flop synchronizer. It follows 3 steps. First, we convert the pulse to a toggling level signal in the source clock domain. Each time a pulse occurs, the level signal toggles. This guarantees that the signal remains stable long enough for the destination domain to sample it correctly. The further steps are in destination clock domain. Here, we first synchronize this toggling level signal using a standard 2-flop synchronizer, and finally regenerate a single cycle pulse from this synchronized signal. A simple XOR between the synchronized signal and its delayed version produces a clean 1 clock cycle pulse in CLK2 domain. I have covered this 3-step method in another video in detail. The link is in description. This is all for this video. Hope this is helpful.